Welcome to MyProjectBazaar.com. Let me discuss about the project Neighborhood Discriminant Hashing for Large-Scale Image Retrieval. Let me discuss about the abstract of the project. With the proliferation of large-scale community-contributed images, hashing-based approximate nearest neighbor search in huge databases has aroused considerable interest from the fields of computer vision and multimedia in recent years because of its computational and memory efficiency. In this paper, we propose a novel hashing method named Neighborhood Discriminant Hashing (NDH) to implement approximate similarity search. Different from the previous work, here proposed to learn a discriminant hashing function by exploiting local discriminant information, that is, the labels of a sample can be inherited from the neighbor samples it selects. The hashing function is expected to be orthogonal to avoid redundancy in the learned hashing bits as much as possible, while an information theoretic regularization is jointly exploited using maximum entropy principle. As a consequence, the learned hashing function is impact and no redundant among bits, while each bit is highly informative. Extensive experiments are carried out on 4 publicly available datasets, and the comparison results demonstrate the outperforming performance of the proposed NDH method over state-of-the-art hashing techniques. We discuss about the flow diagram for our process. Initially, we have to generate the data matrix using feature extraction method. Here there are 4 feature extraction method: GIST, SIFT, pixel and BW feature extraction methods are used. Next, in the hashing function, hashing bits are generated. Hashing based approximate nearest neighbor search in huge databases has become popular owing to its computation and memory efficiency. Popular hashing methods: locality sensitive hashing and spectral hashing. Construct hashing functions based on random or principal projection. The resulting hashes are either not very accurate or inefficient. Moreover, these methods are designed for a given metric similarity. On the contrary, semantic similarity is usually given in terms of pairwise labels of samples. Next, in the estimation of probability, determine the nearest neighbors both in original space and also Hamming space are estimated. Next, in the neighborhood discriminant hashing analysis, developing accurate and powerful electromyogram driven process controllers that can provide the amateurs with effective control on their artificial limbs has been the focus of a great deal of research in the past few years. One of the major challenges in such research is extracting an informative subset of features that can discriminate between the different form movements. Next, in the here the derived the objective function and updated the transformation matrix. Next, the information theoretic regularization are performed. A basic problem in contingency table analysis is clue clustering, simultaneous clustering of rows and columns. A novel theoretical formulation views the contingency table as an empirical joint probability distribution of 2 discrete random variables and poses the co-clustering problem as an optimization problem in information. Using the practical example of simultaneous word document clustering, it is demonstrated that our algorithm works well in practice. Next, the convergence criterion satisfied, then the transformation matrix are updated. If not, then we have to once again estimate the probability using nearest neighbor, and finally we obtain the result of transformation matrix. Based on the transformation matrix, we retrieve the relevant images. Optimization by gradient descent: to optimize the objective function, we propose an iterative optimization strategy and the orthogonal constraint into a penalty term added to an objective function. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click that file and run for executing this process. And this is the main window. And here we perform the neighborhood discriminant hashing for large scale image retrieval by pressing any one database images folder and select any one images from the folder, and by performing here display the input image in this access location. And here now we performing the data matrix for entire dataset images, and this process will be repeated for entire dataset matrices and calculated the feature extracted values. Here the test features are displayed in this table, and these features are estimated using GIST algorithm, and this process will be repeated for entire data matrix, and this will take some time for executing. Now the data matrix are obtained. This will be displayed in the data matrix table, and now by pressing the hashing bits in the space provided, here the range of the hashing bits among these values. Now I press enter, and we have obtained the press LHS hashing function button. We calculated the hashing function and binary bit value, and here I display the number of images, also dimension of features using the GIST feature extraction method. And by pressing the NDH analysis button, we perform the NDH operation. Here the NDH operations are performed for our query image as well as the entire data matrix images. This process will be performed for neighborhood discriminant hashing. Here the nearest neighbor and also probability of the DH algorithm will be calculated, and the objective functions are derived. We obtain the probability using NDH, also the objective function, also we obtain the transformation matrix which was performed using optimization method. By pressing the retrieval images button, we can retrieve the specified images from the folder, and here the elephant images message box will be displayed. Now by pressing the next button, we go for the performance analysis graph. Here select different values of weighting parameter and choose the MIR flicker radio button. We obtain the different values of weighing parameter graph, and by selecting the CAFR dataset, we obtain the different values of weighing parameter for CAFR dataset, and by selecting the NVS wide, we obtain the NVS wide graph. Also shift1m function, we calculated the shift dataset, and likewise by selecting the precision with the Hamming ranking, we perform MIR flicker dataset, and we obtain the precision with the Hamming ranking for our NDH and also a existing method. And for CAFAR 10 dataset, we obtain the precision with the Hamming ranking, and NUS wide we obtain the NDH and also existing method. For shift1m dataset also we obtain the precision with Hamming ranking result. Now by selecting the precision with Hamming radius 2, we obtain the MIR flicker with Hamming radius and also compare with existing method. For CAFAR 10, we obtain the precision with Hamming radius 2, as well for NUS wide also we calculated, and for shift1m dataset also we obtain the Hamming radius 2 result. Precision curves with 24 bits. For MIR flicker, we obtain the precision versus number of bits and compare with existing method. CAFAR 10 dataset also we obtain the precision curves with 24 bits. In NUS wide, we obtain the number of bits and also precision result. shift1m dataset, we also obtain the precision result, and pressing the precision recall curves with the 24 bits, perform the MIR flicker dataset, CAFAR 10 dataset and NUS wide dataset, also shift1m dataset. By pressing the precision of the images from shift1m data, we obtain the synonyms result versus indicates also existing method. And for computation complexity, we calculated the computation complexity for k nearest neighbor, and also hashing function, also total cost, generate the binary codes. These are the computational time for our process. Finally, we retrieve the relevant images using neighborhood discriminant hashing algorithm. This algorithm outperforms with the existing method. Thank you.